Hello. I don't know what time you're watching this, maybe midnight. So I could say good evening or maybe morning. I could say good morning or maybe afternoon after lunch. So good afternoon or maybe not good night, obviously, because it might become good night because halfway through you might go to bed thinking this is boring. Anyway, welcome back. My name is Susale Mohana. In fact, this morning I was thinking, why am I doing this? It was because I remembered that how I became interested in maths. I had a fantastic teacher when I was doing my 9th and 10th standard, which is equivalent to your GCSEs. We had one Mr. Sitaram Shastri. He was a brilliant teacher of geometry, brilliant teacher of arithmetic and algebra. I mean, those it was strictly algebra, geometry, and arithmetic as three separate sections. And he was the one who triggered an interest in me. And that's how I took up maths. So this is one way of acknowledging a thank you to wherever he is. I think he's no more, but may his soul rest in peace. It is, in a way, I'm inspired, or I was inspired to become a student of mathematics because of him, and because I became a student of maths, I became a teacher of mathematics. Because I became a teacher, I'm able to teach now. Hope I'm able to inspire at least one or two of you to take up a deeper study of mathematics. If I don't think I have the ability to do that, but if I could, or even if by sheer accident or sheer coincidence, some one of you starts thinking of doing a degree in maths, my job is done. Welcome. Oh yeah, my name is Susale Mohana. I'm a maths teacher. I've taught maths for a long time, and I'm doing these lessons to help students revise what they have learned in class. I'm not replacing the classroom teacher. I'm just helping you revise what you learned in school. Welcome back. So in the last two lessons, I went over how to deduce the graphs and properties of sine theta, cos theta, tan theta being periodic functions, sine and cos oscillating between -1 and 1, and tan oscillating between -infinity and +infinity, but all the three are periodic. Sine and cos of period 0, 360, whereas tan is period 180. That's two lessons put together in 2 minutes. Brilliant. Now, let's see sketching graphs of COSEC theta, sec theta, and COT theta. Just out of interest. So that, because remember, I didn't give you a handout on it, but I did discuss reciprocal graphs. That's what I'm going to use. Let's look at the sine graph for the moment. Sine graph is, that's 1. Oh, let me make 1 here. That's -90, -180. Can you see here? Or shall I draw a bit to the right? I think I'll draw a bit to the right. Right? So here is, these are rough sketches, so it doesn't have to be very accurate, but it should show the divisions. So -90, -180, -270, -360. It goes on, of course. -180, -90, 0, 90, 180, 270, and 360. Let's say this is 1. Of course, if that is 90, 1 is somewhere there. So we have different scales on different axes. That's your y, that's your x. I'm interested in cosec theta. So I'm going to draw the graph of sine theta. Remember, cosec theta is 1 over sine theta. So I'm going to draw the graph of sine theta by a dotted line. Sine 90 is 1, 0, minus 1, and then, so if I were to draw this, there's a reason why I'm drawing this. I'm going to use the same graph for both cosec and sec. Then minus 90, 180, 270, 360. So your sine graph, of course, it goes somewhere there, right? 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 Okay. Right? All right. All right. And it goes somewhere. That's your sine graph, correct? Very good. Now, I want cosec theta, y is equal to sine theta. Cosec theta is 1 over sine theta. Okay. Remember, so the values of cosec theta depend upon the values of sine theta. If sine theta is 0, cosec theta will be 1 over 0. Remember, we discussed this under asymptotes. So 1 over 0 is undefined, but it tends to infinity. So therefore, I am using green. So at 0, it is an asymptote. (90) and 1 is maximum. Remember, if that is maximum, 1 over, it becomes minimum. So that would be a minimum. At 180, it is 0. 1 over 0 is 180, sine is 0. So 1 over 0 tends to infinity. So therefore, that is an asymptote. Now look at, so as the angle goes from 0 to 180, cosec theta decreases from positive infinity, reaches 1 a minimum value, goes back to positive infinity. Agreed? Now, what happens when you go beyond 180? Sine theta is negative, cosec theta is negative. Sine theta is 0 and moving towards negative, cosec theta tends to negative infinity at 180. So from positive infinity, it jumps because it's an asymptote. At 270 minus 1 is a maximum, is a minimum, so therefore it's a maximum. And then at 360, sin theta is 0 tending to be positive, therefore, well, that is again an asymptote. So look, as long as you're behind 360, so that's the graph of cosec theta. So cosec theta can never be less than 1. Cosec theta can never be more than minus 1 if it is negative, meaning there is no cosec theta from minus 1 to 1. And cosec of 0 is infinity, cosec of 180 is infinity, cosec of 360 is infinity. Similarly, I will leave it to you. I mean, when you get time, stop the video at this stage, copy the diagram, and then you complete this bit and keep it for your records. As I told you, my drawing skills are poor, so I don't want to do it. Alright? Now, I want to show you how to draw the graph of sec theta. You get the idea now, reciprocal graphs. So, I will once again discuss so that you understand. So, this is the advantage of knowing reciprocal graphs. It's easy to draw using the original one. So, let me draw cos theta now, as usual. Okay. Ooh, that's x-axis. That's your y-axis. 0, 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360, 1 and minus 1. I said I'm going to draw this. This is minus 1, that is 1, that is y. This is 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360. That's 1, that's 0, that's minus 1, that's 0, that's 1. That is 0, that's minus 1, that is 0, that's 1. Okay. So this is the, of course it will come down there. This is the graph of cos theta. Yeah. Let me start from this end and go ahead. I don't want to go beyond 360. Look, at 360, oh, I'll use red now. Okay. At 360, cos theta is a maximum 1. So sec theta will have, of course, sec theta, y equal to sec theta is 1 over cos theta. Cos theta is a maximum 1, so sec theta will have a minimum. At 270, cos theta is 0 and positive, so sec theta is positive and tends to infinity. So that becomes an asymptote. So sec theta tends to infinity. The moment you cross minus 270, go towards minus 180, cos is negative, sec is negative, cos is 0, sec is negative infinity, tends to negative infinity. This is minus 180 minus 1 is a minimum, so that becomes a maximum. At 90 again, it's an asymptote, so therefore you have that graph like that. Okay? At minus 90, between minus 90 and 90, cos is positive, so cosec is positive. Cos is 0, cosec is infinity. Cos is 0, cosec tends to infinity. Cos maximum is 0, 1, so cosec minimum is 0, 1. So you have drawn the graph. Then you will be able to draw the other two graphs. I will leave it to you, as I said in the previous case, to do it. So I am using the properties of a reciprocal curve to draw. And the period of cosec is the same as the period of cos. Period of sec is the same as the period of cos. The period of cosec is the same as the period of sine. And obviously, if sine is positive, cosec is positive. So ASTC applies. When you say S includes cosec, sine includes cosec. When you say T, tan includes cot. When you say C, cos includes sec. Okay? Now, let me just draw the graph of tan theta. Sorry, cot theta. These are just discussions. Sometimes they ask you to draw a sketch, so you should know. And I thought that will be a chance for me to discuss how to apply reciprocal graphs as well. So I'm going to do only the positive side. I can do the negative side, why not? That's minus 90, minus 180, 0, 90, 180. Remember, I didn't go beyond, because the period of a tan function is 180, that's why I'm not going beyond 180, right? So tan 90 is infinity, tan minus 90 is infinity, so the graph of tan is like that. Right? That's y, that's x. So y equal to cot theta is 1 over tan theta. Let's start from 0 between minus 90 and 90. Look, at minus 90 here, between this, tan is negative. So cot is negative. Tan is tending to infinity, so cot will be 0. Tan is 0, so cot will go to negative infinity. So that's the graph. Here, as you move further, interesting. As you move from minus 90 to minus 180, tan is positive, so cot is positive. Tan is decreasing, cot is increasing. Tan comes to 0, cot goes to infinity. So that's your graph. Very good. At 0, to the right of 0, tan is positive, cot is positive. Tan is increasing, cot is decreasing. Tan is 0, cot tends to positive infinity. Tan 90 goes to infinity, tends to infinity. So cot 90 comes to 0 or tends to 0. So it starts from infinity and tends to 0. And obviously, you can draw the other bit of the graph like that. So It's just a question of up, down, left, right, above, below, decrease, increase, infinity, 0, 0, infinity. So if you can think of those lines for reciprocals, it's the easiest way to draw the graphs of COSEC, SEC and COT. So to recollect, and again, so any angle between 0, 90, 180, 270 and 360, I could go 270 the same as minus 90, I'm not saying equal, is equivalent to. So minus 90 cannot be equal to plus 90. I mean minus 90 cannot be equal to 270. But the angle minus 90, if you plot a point, plot the angle minus 90, you can as well draw the angle plus 270. Both, how would I put, the sense in which you measure the angle changes, but the final angle remains the same. Alright, so this is negative, that is positive, A, S, T, C. Well, that was a brief discussion of why in certain quadrants certain ratios are negative and in certain quadrants certain ratios are positive. So now that's about 16 minutes. Should I take 4 minutes to see how to apply? I think in general, suppose I wanted to find out, let's assume theta is an acute angle. Then what is sine of 180 plus theta? Just taking a simple example. So remember, I'm going to use this A, S, T, C, 0, 90, 180, 270, 360, or 0, minus 90, minus 180, minus 270, minus 360. Yeah, still the same. Now, I want an angle 180 plus theta. I didn't say minus 180 plus theta. That means I am measuring 180 in anti-clockwise direction, a theta in anti-clockwise direction. So that's minus 180, that's theta. That's your angle. Okay. Now look, that's the angle theta, that's the opposite, that's the hypotenuse. I can find and sine opposite by hypotenuse. So, but which quadrant am I coming to? Third quadrant. So your sign is going to be negative. The moment you write a negative sign, you're not bothered about the quadrant. Now the quadrant is finished. We are back to a normal right angle triangle which you learnt in GCSE. By putting a minus sign, you have accounted for the displacement. Now, in a triangle, we are looking at, you can't have a triangle with a negative distances or negative lengths. So we're looking at now the distances or the lengths. So you can find sine theta opposite by hypotenuse. So that is sine. So sine of 1, in other words, what you do is 180, 360, 720, minus 180, minus 360. Locate which quadrant the angle comes to, decide whether it's going to be positive or negative. Once you decide it, forget about the signs, forget about the displacement, think of a right angle triangle and then work out what is sine or cos or tan. So that is how we do that. So similarly, see, if you have, for example, 90 instead of 180, cos of 90 plus theta, or tan of 270 minus theta, things like that, 90 and 270 are odd multiples of 90. Then sine becomes cos, because by similar triangles, opposite becomes adjacent, adjacent becomes opposite. So sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan. Tan of 270 plus theta, 270 plus is in the fourth quadrant, so tan is negative, 270 is odd multiple of 90, so therefore tan becomes cot. So it is minus cot theta. So it's easier to it's easier to figure out when you have a 180 because the triangles don't change. But if you have, it's something like a rotation. So if you have a rotation of an odd like 90-degree rotation, the horizontal becomes the vertical becomes the horizontal. So that being the case, your sine and cos get interchanged. Okay, let's keep that in mind. In the next lesson, I'll take some examples of these and we go back to applying these concepts and also the three identities which we proved in 2-3 lessons ago. I'm coming back to that. I told you trigonometry is the most important part of A-level syllabus and beyond. Okay, have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.